Present here is 4 probe method. So the aim of this experiment is to determine the band gap energy of a semiconductor, which is usually germanium or silicon, using 4 probe method. So the theory for 4 probe method is 4 probe method permits the measurement of resistivity in samples having wide variety of shapes, including the resistivity of small volumes within bigger pieces of semiconductor. This is applicable to silicon and other semiconductor materials. 4 probe arrangement consists of 4 collinear metal probes. A constant current I passes through the outer probes and potential difference is measured between the inner probes, which are coupled to a high temperature voltmeter. 4 sharp probes are placed on a flat surface of the material to be measured. Current is passed through the 2 outer electrodes and the floating potential is measured across the inner pairs. If the flat surface is considered to be a semi-infinite volume, there will be no surface leakage. So the figure here shows the representation of 4 probe arrangement. When a current is passed through the semiconductor, an equipotential surface is formed and we measure the potential difference across it. The inner probes does not draw any current because of high input impedance. When a current I passes through the semiconductor, current density J is given by J is equal to I by 2 pi r square. We know that E is equal to rho J. So therefore, E is equal to J rho by 2 pi r square, which is equal to minus dV by dr. On integrating, V is equal to I rho by 2 pi r. The potential difference at probe 2 is V2 is equal to rho I by 2 pi into 1 by S1 plus S2 minus 1 by S3, where S1 and S2 are probe spacing. The potential difference between probe 2 and probe 3 is given by V2 minus V3, which is equal to V, which is equal to rho I by 2 pi into 1 by S1 plus 1 by S3 minus 1 by S1 plus S3 minus 1 by S1 plus S2. Then the resistivity rho is given by rho is equal to 2 pi V the whole divided by I into 1 by S1 plus 1 by S2 minus 1 by S1 plus S3 minus 1 by S1 plus S2. So let S1 is equal to S2 is equal to S3 is equal to S. Then rho is equal to rho 0 becomes rho 0 is equal to V by I into 2 pi S, or rho 0 is equal to 2 pi S into V by I, which is usually represented in omega centimeter. This is the equation used for semi-infinite volumes. In practical case, this is not used. We need a correction factor to find the actual resistivity of small volumes of W by S, where W is equal to width and S is equal to probe spacing. So, rho equal to rho 0 divided by F of W by S. The band gap energy of a semiconductor is given by Eg is equal to 2K into 2.303 log rho whole divided by 1 by T electron volt, where Eg is equal to band gap energy, K is equal to Boltzmann's constant, rho is equal to resistivity of semiconducting material, T equal to temperature in Kelvin. The function f of W by S refers to the value in table. A graph is plotted between log rho and 1 by T in Kelvin into 10 cube. The slope of the curve AB by BC is calculated. Now for the procedure of 4 probe method. The sample is placed on a base plate of 4 probe arrangement. Connect the outer pair of probes which leads to the constant power supply and inner pair which leads to the voltage terminal. Place the 4 probe arrangement in the oven and fix the thermometer in the oven through the hole provided. Switch on the AC mains of the setup and put the digital panel meter in current measuring mode. Through the selector switch, set current equal to I. Put the digital panel meter in voltage measuring mode and note down the voltage corresponding to increasing temperature. Calculate rho for each voltage. Draw a graph between log rho and 1 by T. The slope is calculated and hence the band gap energy is calculated using the formula Eg is equal to 2K into 2.303 log rho by 1 by T electron volt. If any W by S value is not found in the table, plot a graph between W by S and F of W by S values. From the graph, the values of F of W by S corresponding to any values of W by S can be obtained. So this is the procedure for to find the band gap energy using four probe method. So this figure shows the four probe method. Here as we can see the four probe setup as well as oven. There is a hole provided in the oven to place the thermometer. This is how we record our observations for this experiment. The voltage variation with temperature is noted. The temperature is noted in Kelvin and we take the value 1 by T into 10 cube, which is represented in Kelvin inverse. We note the corresponding values of voltage for heating as well as for cooling. Now a graph is plotted between log rho and 1 by T into 10 cube. We can see a straight line is as shown in the figure, and from the figure we calculate the slope and we substitute in the equation of Eg to find the value of band gap energy. So here we are using the semiconductor used here is germanium. So the result is the band gap energy of germanium, which is equal to approximately 0.7 electron volt. That's all for my topic.